So for problem number 1, we have to determine which of these triangles are similar. Now we've got a couple ways to prove similarity. One is today we're going to talk about side, 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 and side angle, side. So there's a similarity or a similarity theorem that if I could prove that the sides are similar, then the triangles are similar, and then side angle side helps with that too. But don't forget, we're also reviewing angle angle. So if I have two triangles that I could show are congruent, then I can prove that the two triangles are congruent. So one thing that I love to look for is I call them bow tie scenarios. See how this looks like a bow tie? First of all, I can find this angle. I believe that this angle is congruent to this angle. And the way that I can figure that out is I believe that angle QYD is equal to, and here's how I'm going to find that. This is a straight line, right?
Yeah.
This is a straight line. So what is this angle? How can I find this angle?
92.
No, this is 92, but what's this one I marked off here?
Oh, it's whatever equals 180.
Yeah, so it's 180 minus 92, correct? Does that make sense to you guys? So let's figure that out. I got my handy dandy calculator. 180 minus 92. Well, bam, with the bacon sizzle. It equals 88 degrees. But now, if this equals 88 degrees,
88 or 80?
88. I know, and I erased the 0 and I put an 8. Oh. Yeah, there's something wrong with me. I'm not awake yet. First problem of the day. All right. So it's 88. Now, what about this angle right here? Guess what? It's the same thing. I can find this angle by saying 180 minus all this stuff, 92. So this is also 88 degrees. Why do I want to keep writing 80? It's bizarre. So those two angles are congruent. Now, if I can find another pair of angles in this bow tie figure that are congruent, then what?
Oh. Sorry.
Oh. So what are these called? Vertical angles. So we know that vertical angles are always congruent. So I have two sets of congruent angles. So that must mean that this triangle is similar to this. So I want to be careful on how I say it, and I'll probably going to say it a couple times today. I'm proving two pairs of congruent angles. So I'm proving the similarity by angle. So then I just got to see which one matches up. So I have, it's not this one. It's not EYQ. No, it's not that one. PYE. No. Let's see. DQY, yep, that's DQY, and then DEG. So C is the correct answer. So yeah, D. My first problem of the day. I'm a human being. Well, that's true. I only had one cup of coffee. I woke up kind of late, actually. Anyways, does that make sense to you guys, even though I can't speak properly today?
Uh-huh.
All right. Let's move on to the next problem. Now, it says, which triangles are similar in the big triangle, are similar to BCE? So if I look at this, I have B, C, E. Now, if I were to guess, what do you guys guess and think that it is?
GDF.
We think that it's GDF, right? Triangle GDF. So I got to prove it though. So I look, and this one we could do like it's interesting. This one's going to be a difficult one to prove. So I'm just going to think out loud. I notice that this side length is 24, and then this side length is 10 and 24, right? And then this side length is 24. And then when I add this up, though, is that 24? In other words, what's 12 plus 9? Yeah, it's like 21 something, right? But this is 24. So I don't know if they're going to be similar because their side lengths are not proportional. So let's start with some congruent angles. Is there an angle that I can prove is congruent or shared? Let's look at the angles though. If this is 73, well, let's add this up. What's 32 plus 75? 32 plus 75 equals 107, and if I subtract 180 from that, I get that this is 73. Okay. So the angles are congruent. This angle is congruent, but I don't really know if this is 32 or not. So that doesn't really help me a whole lot. It almost appears as if GDF is congruent, but we're looking for similarity. I did notice, though, notice how these two sides are congruent. Do you guys notice that? In order for it to be proportional, the side lengths, basically this is an isosceles triangle, right? So we've got triangle BCE is isosceles. And if we look at the information that we're given, this is 24 and this is 24. Okay? And we know that this angle here is 73 degrees. And that's really all we know. So we could do the side angle side theorem, but the angle isn't trapped between the sides. So I don't really know for sure. It could be this one, right? It could be DEH because it's trapped within it. But if you look very carefully, this is not a parallel line, so that won't work. Boy, this is a tough one. I really believe that at the end of the day, we're going to have to, I really believe it's ABG. The question is, how do we prove that it's ABG? In other words, if I look at ABG, it's a similar triangle, and I have 8 and 8, and that's an isosceles triangle. So in other words, I have a scale factor of 3, but in order to prove that, I've got to prove that this side is similar to this side. Well, I know this is 6, but I can't really prove the length from here to here. In other words, if I could prove, what's 6 times 3? 18. If I could prove the length from here to here is 18, then I could probably, because it has a scale factor of 3. If I could prove another angle somewhere. Well, if this is an isosceles triangle, then this would be 73 degrees as well, right? So what angle would that give me here? 180 minus let's do 180 minus 73 times 2, right? 2 times 73. So this would be 34 degrees. So if I could prove that this is 34 degrees somehow, oh, you know what? I can. Because the bigger triangle, actually, I think it's just the bigger triangle. Let's look at this one. Now, Mr. Adams knows the answer, but I'm purposefully trying to go through and eliminate the possibilities. The bigger triangle, ACF, I have 8 plus 24, so 8 plus 24 is 32. I have 32 on this side because I have 8 plus 24. I know that this angle is 73, and I calculated and found that this angle is 73. So because it's an isosceles triangle, this is 73. And wait though, it says that this is 32. Well, yeah, that's or 34. That's right. I'm looking at the bigger. Let me highlight it so you guys can see. I'm looking at the bigger triangle, so I'm saying that I'm proposing that these two are similar. Now, there's lots of ways I could do it. I think I could do it by angle, but the proportionality is the same, right? So it's actually ACF. Thumbs up if you understood what we did there. Thumbs down if you don't understand. Okay, so for those of you that didn't have thumbs up, let me go over it again. Our original triangle was BCF, which is this right here. Okay? And Mr. Adams just started listing facts and finding things and solving things based on what I know in geometry. We were given that this was 73 degrees. I found out that 10 plus 14 equaled 24. So that meant that it's an isosceles triangle. And for an isosceles triangle, the base angles are congruent. So then that means that this angle is 73 degrees. Okay? With that information, I can add those two up, which is like 146, and subtract it from 180 to find the remaining angle, which is 34. Now this angle is angle A, or not angle A, it's angle B. Then I went through and just started thinking out loud. Could it be this? No. I couldn't prove that. Could it be a different triangle? No. I couldn't prove that. So then I said, well, look, I know that it has to be an isosceles triangle. And I looked at this. Can't be isosceles because 10 does not equal 9. Then I looked at this one. 12.6 does not equal 14. So it can't be this one. It can't be this one. Then I thought maybe it's this one. But technically I have no way of proving it. So it's not that one. And I was kind of stumped. It can't be this one because this is 75 degrees. So what's left? The only thing that's left is this great big triangle. And I said, well, let's see what I can figure out about that great big triangle. Well, if I add 8 plus 24, this would be 8 plus 24. That equals 32. Now, on the other side, I could say 8 plus 24. That equals 32. I've calculated in a previous thing that this angle F was 73. And I know that angle C is 73 just based on the fact that it's an isosceles triangle. From there, I've basically proven it through an angle theorem. But to double check, the math's going to be the same. This will be 34 as well. So I've proven this by the angle theorem of similarity. It just took me a while to get it. Okay? That's one of the more difficult. There'll be one like this on the SAT. So the more we practice these types of problems, this, by the way, after doing a difficult problem like that, isn't this a piece of cake? No? Oh, I appreciate your honesty. Can we move on to the next one, though? Yes. All right, so now we'll do something a little easier. On problem number 3, it says the triangles are similar, find the value of x. So again, I'm just going to set up my proportion because that's how we solve these. So I'm going to say something over something equals something over something. So on my small triangle, I'm just going to pick x is RS, right? So I'm going to say RS. I need to know that. And then I'm going to pick any other side length. So I'm going to say RT. Now, R has one arc. So what corresponds to R on the small triangle? A. Now, S has 1, 2, 3 arcs. What corresponds to S on the small triangle? C. And then T has 2 arcs. B corresponds to T. Does that make sense? All right. Moving along, RS is X all over RT, which is 77. A to C is 45. And then A to B is 55. So 5/7 is the thing. So I think X is going to be 63, but we'll figure it out. So now I'm going to cross multiply. Over here I'm going to say 45 times 77 is equal to 55x. And I'm going to take my calculator. And I'm going to say 45 times 77. That's 3,465. And that's equal to 55x. Okay? Next step, what do? I'm going to divide by 55. Oops, why am I just writing whatever? Okay, so I divide that by 55, and I get 63 equals x. Okay? So we'll say this is 63. Any questions on that one? Alright. Let's move along. For problem number 4, it says 2 trees are growing in a clearing. The first tree is 16 feet tall with a 10-foot shadow. So we've done this problem before. It's 16 feet and a 10-foot shadow. The second tree casts a shadow of 34 feet. I know you can't see it because I'm trying to do this. So then, do I know how tall that is? No. When I don't know something, I'm going to use x. So I'm going to set this up. I'm going to say x over 34. What corresponds to x on the other triangle? 16 does. And what corresponds to 34? 10. What do I do next? Cross multiply. So I get 10x is equal to 34 times 16. So I'm going to say 34. I get 544, right? So I'm going to say 10x is equal to 544. What do I do next? Divide by 10 on both sides. And I'm going to get x equals 54.4. Now I have a decimal and it says how tall to the nearest tenth of a foot. Well, it's just 54.4 because my answer already is to the tenth. So it's 54.4 feet. Okay? Any questions on that one? 54.4 feet. So now for problem number 5, it says find the value of x. It tells us what corresponds to what, and I like to double check sometimes. So x is nt, and then I'll just pick another side. We'll do ut. It really doesn't matter as long as we get the correct corresponding parts. So what corresponds to n? H. What corresponds to t? K. I'm literally just looking at the labels. U is the second letter. What corresponds to U? V. And then T corresponds to what letter? Somebody said H, but what is it really?
Okay.
K. All right. So NT then is X, UT is 57, and we're going to set that equal to HK, which is 34. And then VK is 38. So moving over here, I'm going to cross multiply. 34 times 57 is equal to 38x. So I'm going to say 34 times 57. And that is 1,938 is equal to 38x. What do I do?
Divide by 38.
Divide by 38. And I get 51. 51 is equal to x. Any questions on that? Okay. Moving on to the next problem. We're told that CP from here to here is the median, and we know the FQ is the median too. So I'm going to say we're asked to find CP. And that corresponds to FQ because this is the median. Remember, the median, it goes from the vertex to the midpoint. I know that Q is the midpoint because this side length, or this segment is 30 and this is 30. So the midpoint divides the opposite side into two equal congruent parts. So now I could pick AP, and A corresponds to D, and P corresponds to Q because those are the midpoints. Does that make sense? So now it's just plug and chug. I'm going to say CP all over AP, but AP is 24. That's equal to FQ, which is 45. And then why did I put DP? It's DQ. You guys got to catch me on this stuff. God bless you. Oops. So DQ is actually 30, right? So again, I'm just going to cross multiply. I'm going to say 45 times 24 is equal to 30 times CP. I'm going to take my calculator out. And I'm going to say 45 times 4. I get 1,080 is equal to 30 times CP. What do I do? Divide by 30. I think it's going to be 36. Let's see. So now I divide by 30. Yeah. Okay. Does anybody have any questions on that? Real quick, while people are finishing writing this down, where are you at on these types of problems? Thumbs up if you can do this on the test. Thumbs down if you're going to fail miserably or if you're lacking confidence. Okay. So for the thumbs downers, what do you think the issue is? Do you think it's the setup, picking the sides? Oh. Okay. Anybody else? Next week sometime. All right, let's move on. We'll just keep plugging away. Hey, luckily for you, we have another problem just like the last one.
Is you recording too?
Yep, I'm recording right now, so so again, same problem, different numbers. We know that CP is the median of this triangle and that FQ is the median of this one. I'm going to go with the exact same setup. I'm going to go with CP corresponds to FQ. Bless you. And then I'm going to pick AP, and that's going to correspond to DQ. So again, we're trying to find CP, so I'm going to say CP over AP, which is 2, FQ, which is, oh wait, no, look, they give us an expression. Whoa, whoa, it's 6x minus 20. What the deuce? And then I have 5x minus 12 all over 4. Okay? Solve this one the exact same way. I'm going to cross multiply. But let's put these expressions in parentheses. And that way when I cross multiply, I'll remember that I'm multiplying 2 times the quantity 5x minus 12. Because I got to multiply both terms by 2. And then on the, likewise, on the other side, we're going to put 4 times the quantity 6x minus 20. Now the reason I do that is I want to remember that I'm going to multiply 2 times 5x, right, which is 10x. Then again I'm going to multiply 2 times negative 12, which gives me a negative 24. And then I'm going to multiply 4 times 6x, which gives me a positive 24x. And then I'm going to multiply 4, I'm using the distributive property, times negative 20, so that's going to be a negative 80. Whew, that's a lot of work. Alright, so now to solve for x, I need to get the x on one side and all the other stuff on the other. So I'm going to pick the smaller one, which is 10x. I'm going to subtract 10x, because I want to move everything away. If I have 10x's and I subtract 10x, doesn't that become 0? Yeah, so that will leave me with negative 24 on this side. But remember, when I add or subtract something from an equation, I have to do it to both sides of the equal sign. So I'm going to subtract 10x from both sides. So 24x minus 10x is 14x, and now I've got the negative 80. I want to move the 80 to the other side. How do I eliminate 80? I got to add 80. And whatever I do on one side, I got to do on the other. Uh-oh. Quick maths. I got negative 24 plus 80, negative 24 plus 80, well, bam, with the bacon sizzle, that gives me 56. It's not an S, it's my 5s, I can't change it. 14x is what it's equal to. What do I do next? Yes, she says with enthusiasm, divide by 14. Oh, doing too much. 56 divided by 14. I'm pretty sure the answer is 4. Yeah. So I get 4 is equal to 14 divided by 14 is 1. 1 times x is x. Now, this is not the answer, is it? No. That's the value of x, but what did the question ask us? We got to plug it in. So CP... CP is equal to 6x minus 20. But we know that x is equal to 4. What's 6 times 4?
24.
What's 24 minus 20? 4. Isn't that ironic?
I just did.
That's the actual answer. So this whole thing equals 4. Okay? Any questions on that one? All right, so for problem number 8, we're going to move forward and we're going to do this area problem. They tell us that the area of this big bad boy is this. We need to find the scale factor. So the one-dimensional scale factor is we're going to move backwards, right? So you're going to say, what is 15 divided by 60? Well, if I reduce that down, it's 1 over 4. Okay? That's the one-dimensional scale factor. So now for a two-dimensional scale factor, we're going to take the single scale factor, the one-dimensional scale factor, and what are we going to do with it? We're going to square it. So that's going to be 1 over 4 squared, which is actually 1 over 16, which 1 over 16 is the same as dividing by 16. Now, where does that come from? In order to get RS, the length of RS, I would have to take XY and divide that by 4. Does that make sense? Because I'd have to take 60 and divide it by 4 to get 15, right? Well, now for this side, I would have to say 1/4 of ZY. To get the length of TS, I'd have to say 1/4 whatever the length of this is. So when I do the area, I'm literally multiplying 1/4 by 1/4, which is 1/16. So I can find this answer simply by saying 2160 divided by 16. Well, let me write it a different way. 2160 over 1 times 1/16, which is 2160 divided by 16, which if I plug in my handy-dandy calculator, 2160 divided by 16 gives me 135. So what did I just do? I found that the area of this thing is 135 square inches. Does that make sense? All right, let's do problem number 9. It says, determine whether the triangles are similar. If they are, write a similarity statement. So this is probably going to be an angle because it's a right angle. So I know that this is equal to 90 degrees and this is equal to 90 degrees. So I know that the measure of angle W is equal to the measure of angle L, which is equal to 90 degrees. Now angle B and angle G are 51 and 39. Let's find out what the measure of angle D is. So the measure of angle D is equal to 180 minus 90 plus 39. Now, where does that come from? All three of these angles have to add up to 180. So this angle is the sum of these two subtracted from 180. So I'm going to plug that in my calculator and see what I get, okay? 180 minus the quantity, 90 plus 39. I think it'll be 51. Yep. So the measure of angle D is 51. So this is 51 degrees. Hey, B is 51 degrees. So I would say the measure of angle D is equal to the measure of angle B, which is equal to 51 degrees. And then we would just say triangle BOW is similar to triangle B corresponds to D, O corresponds to G, and W corresponds to L by angle similarity theorem. Okay? Because I proved 1, 2 angles are congruent. Does that make sense? All right. So I think we're going to stop right there for today. Now here's